doing the can crushing experiment, and to do this we need an empty Coke can, some water, an ice bath, and we've got some water boiling right now. We're going to take a tablespoon of water and put it in this can. Might move around in the pan, so kind of just hold it. You're going to place it in the pan and wait till you see a little steam come out of the opening. And it might take a while. I don't know if you can tell, but there's a little steam coming out of the opening. And once you start seeing that, you should wait probably about like 30 seconds just to make sure the water's hot enough. To explain the can crushing experiment, say we have a can. Inside this can, you have internal pressure pushing outside and atmospheric pressure pushing inside. So this should be balanced, but what happens when we put the can in an ice bath, when you put it in the ice bath, we're going to seal the can off, and the internal pressure will decrease because water vapor will begin to condense. And as it condenses, there will be less water vapor, thus less pressure pushing outside, and the atmospheric pressure will then overcome the internal pressure, causing the can to crush. So we have a dented ping pong ball, and we are going to correct it by placing it in the hot water.
This experiment demonstrates Charles's law. The molar volume of a gas is directly proportional to the temperature at a constant pressure. So when we raise the temperature, the volume of gas inside the ping pong ball increases as well, and it fixes the dent. This experiment is to demonstrate Boyle's law. So in the first trial, I'm going to compress the volume of the syringe. So you start with the valve open, and so when it's open, the air can flow freely, but when you close it, it'll lock it so no air can escape. So you put the marshmallows in, and you lock the valve. And so as I compress this, the volume in the syringe will decrease, so that means the pressure will increase, and the volume of the marshmallows will decrease, which means they'll shrink. You see? Okay, so again. Good. Okay, so for the second trial, we're going to increase the volume of air in the syringe. So again, you lock the syringe, and as the volume in the syringe increases, the pressure will decrease, so the volume of the marshmallows will increase, which means they'll grow larger.
Our next experiment is to demonstrate Avogadro's law. We will be using some Alka-Seltzer tablets, some balloons, and some water to demonstrate this.
We put 1 tablet of Alka-Seltzer in the red balloon, 2 tablets in the blue balloon, and 3 tablets in the green balloon.
So here's 1 tablet.
Close, close, close. Do you feel it?
There's 1. Now we're going to do 2 tablets. I'll just put it directly
I can
in
try
here.
to try this time.
No, that's okay. already.
You can tell.
You can hear it. There is the blue one. 3 tablets.
Add more water.
So here are 3 tablets.
Wait, more water.
Sorry. Okay. There's 3 balloons. As you increase the number of Alka-Seltzer tablets in the balloon, or the number of particles in the balloon, the volume of the balloon will increase. We have 2 devices to measure pressure, a manometer and a barometer. The manometer is made up of a glass U-shaped tube filled with liquid mercury. And this is used to measure gases which typically have pressures lower than atmospheric pressure. So a formula for that would be the pressure of a gas is equal to the pressure of atmospheric pressure minus the difference in this height of mercury. In comparison to the manometer, we have a barometer, which was invented in 1643 by Evangelista Torricelli. A barometer is a glass tube filled with liquid mercury, inverted in a dish also filled with liquid mercury. You would be wondering why the mercury in the glass tube does not spill out into the dish. The reason behind that is that this pressure that is exerted on the surface is balanced out by the atmospheric pressure also exerted on the surface. At sea level, the reading of a barometer should be about 760 millimeters of mercury. However, there are different factors that may make that reading fluctuate. And a storm or maybe high altitudes will lower that pressure.
The equation for pressure is force over area. So the unit of force is in newtons, and the unit for area is meters squared. So 1 newton per meter squared is equal to 1 Pascal. But since pascals are so small, the standard unit of measurement for pressure is 1 atmosphere. So 101,325 pascals equal 1 atmosphere, which also equals 760 millimeters of mercury and 760 torrs.